Alright, so I'm going to show the self-test routine on this. So there's a switch here, which is on, it says 3, 4, 5, 6, 7, board 8. Yeah, A8 board. So that's, when it's in the left position, that's normal. Center position is marked T1 on the board just there. It's test 1. And right position is T2. So these are self-test diagnostics. So you can actually go through and do some basic tests. So I'm going to show you that. You can actually change the switch whilst it's powered up. It seems to be fine doing that. So normally it will step through. If I stick an internal trigger, it will step through each test. And it's supposed to say, in this particular range of resistance, 1,888 on every range. If it doesn't, then there's an issue. And it will come down to a range and it will say, yep, there we go. So milliohm in parallel had an issue in resistance, but series is okay. So I do capacitance, and it does 1,888 on each one as well. I'll do exactly the same process, check each range. PF in series has a fault, but parallel's okay. Yep. And do inductance, same process again. So parallel microhenry range, 2000 microhenry range in parallel was a problem. Let's watch it again. 200, 2000 henries, microhenry, parallel, series okay. Right, so that narrows it down a little bit in those stages. Now you can also step through them, but if you stick it on an external trigger, you can immediately step through each test. So you can actually give you more time to look at it. I've been watching it for a little while now doing stuff, so I've got used to seeing what it's doing. So there you go. Parallel, microhenry, 2000 range, because there's no decimal point, isn't working. We've got a series, which is the next step, next test. That's okay. So these are digital circuitry tests, which means that it's got issues with digital circuits. The digital sections somewhere have got problems. Because the digital tests, which are test 1, and test 2 is the analog tests. So I've already identified there must be some kind of digital problem somewhere. Right, if I go to test 2, you have open and shorts on these terminals here, and it will do different things. So I'll step through those again. I might as well do inductance first. So it should display 1,999 on the display in this particular condition. And so again, it's got issues. Disappeared. And it's got issues on 3 or 4 ranges, something like that. So that's 200 henries, 200 henry range, 2000 henry range in series. Yeah, and a couple other ranges. So I didn't quite catch them all then. So that's got issues. Do capacitance. The same fault shows whether it's got a short or an open on these terminals. It's given the same ranges, so there's obviously issues there. And this should show 000, I believe, or something like that. I can't remember now. But same ranges are given, garbage, right? But so the internal self-test is handy. So inductance and resistance should say 1,999 when it's open. So series K's has got issues. Right, so it has potentially analog issues as well. Certainly digital issues. The digital issues may be the only thing that's wrong with it. There may not actually be analog issues. It may just be that it's causing it to display that way because of the digital fault. So I need to look into this further now and try and figure out what is going on there. This switch is a bit dodgy. I've lubricated it, but it's sticking. I think I actually need grease or something on it. It's binding up, but that's a minor issue. Let's get the thing working first. Oh, knock the camera over. Right, let's check the power supplies just to rule those out if there's a major issue. Oh, got to keep knocking the bloody camera, it doesn't help, does it? Okay, you can still see it, it's fine. So, that is, I believe that's the reference point there. as in 0 volts. There's an 8 volt marking on the board here, and I'm getting 7.8, so I'm not quite sure what the story is there because it's not mentioned in the manual yet. It's not the bits I've read so far. That gives me nothing. Don't know what the story is there. This one here, 12.01, which is within spec. It's supposed to be between 11.95 to 12.05, so that's pretty much bang in the middle. And it's also got 12.009 or minus 12.009, and that should be minus 12.15 through to minus 11.85. So again, that's smack bang in the middle, no problem. And we've got plus 4.997, and that should be plus 4.85 to plus 5.15. So again, pretty much smack bang in the middle. So the power supply voltages coming out look absolutely perfect. Let's check AC. Some ripples coming out of this thing. So we've got this 8 volt supply here first, which is kind of interesting, 260 odd milliamps, millivolts, sorry. Then we've got this plus 12 volt supply, 0.6 millivolts. Yeah. The minus 12 volt supply is minus, oh sorry, again 0.6 millivolts, and the 5 volt supply is 0.4 millivolts. So the AC ripple on those looks absolutely fine, apart from the 8 volt source, which I don't know where that comes from. That disappears off the board somewhere. I think it comes from somewhere else. It's only got the smoothing capacitors on this board. The 8 volts comes from somewhere else. I haven't found out where from yet. Maybe it's a regulator somewhere. Or maybe I won't poke around. I don't want to find out the hard way. So yeah. So those voltages look fine. You can't fault those. The 8 volts may be an issue. I don't know where that's coming from though, and whether that's a critical voltage or not. I need to track that down yet. So we should move on. Okay, so next thing I'll do is do tests on a couple of these ICs here. So these are on the bottom of the unit, and I'm supposed to be checking for functions coming through from the front panel onto these ICs. So I'm supposed to be checking U1, which is this one here. That's U2. On pin 4, and I've got to check for the test signal level, which is this one here. Changing that switch there, changing the state on this pin. So let's find 4. Pin 4 is, that's 1 there, so it's 4 will be that one there. Make sure I get through the conformal coating. Alright, so I'm getting 0.1 volts there, DC. I've got it clamped onto the chassis, so it's just, it seems to be fine for an earth. And so it changes. 3.7 volts. A bit low. I thought it would be about 5, but okay. It should be above threshold though. Okay, so pin 7. So that's 4, 5, 6, 7 is there. It's the next feature. Get through the conformal coding. And I want frequency 120 Hz or 1 kHz, which is this switch here. So it's 3.5 volts now. 0.2. That's obviously switching okay. Now on pin 12, so it is 16 pin devices, so 16, 14, 13, 12 should be this one. Again, get through the coding. And I'm supposed to be doing range hold on off. Yep, that's working okay. And now I've got to check IC, well, U2. So, okay, this was a little bit less clear. So pin 4 again on this one. These probes are on the way out, the tips are getting a bit blunt on them now. Okay, so it's on pin 4. I'm supposed to be checking for circuit mode, parallel series. Okay, shows auto. Okay. Those don't matter, those aren't changing. Auto's coming, that one on. Okay. Alright, it's on pin 4, should be auto. Pin 7. Okay, that's in auto still. It's getting 3.8 volts here, slightly higher, and that's low, and that one's high. There we go. Right. So from those two pins, you can tell what state it's in, which is fine. And then the next one I've got to do is 9 and 12. So 9, it'll be that one. This at least verifies that all the input states are correct. Right, so that's on pin 9. I should be checking for LC and R. Alright, so that's an R. That's in C. And that's in inductance, 5 volts. So it's interesting the other pins they aren't getting lower voltages. I wonder why those ones are lower. That's an interesting little trait, isn't it? Why are they as low as 3.6 volts when that one's doing 5, which is what I'd expect it to be. Anyway, so that's doing inductance on pin 9. That shows up. So on pin 12, 10, 11, 12, that one. So that's showing 5 volts inductance as well. Nothing on capacitance, and resistance got a voltage. Yep, that's probably fine. So those are changing states like I'd expect them to be, so those look fine. Okay, apparently now I've got to check for waveforms. So I need to be checking for waveforms at the A7 card, TP2, 3, 5 and 6. And I've got to check for the waveforms that are there. So that's, I keep missing this card, that's 8, so this might be 7 here. And where are the test points? 2. So checking for TP2. So we'll click onto somewhere. Click on there. So TP2 is this one. Right, let's just do a auto setup on this because I don't know what I was using this configuration for last time. So yeah, it kind of looks like that. It looks pretty much right. It doesn't say what state to leave it in. No, there's no real difference there by changing these switches, it looks like. So that probably doesn't matter. Okay. So that particular one there that's a way better waveform than what's in the diagram, I'll tell you. But it looks similar. It's got a little spike in the centre there. It looks very similar, sloping up at the front edge. It's 127 kilohertz that's running at. But it's a very similar waveform to what's on the manual there for TP2, so that looks okay. So you want TP3 next, which is there. And TP3 is similar. Again, in the manual is not as clear. It's the manual's got it being pretty much flat with a little dip in the center like this. So it's got like a flat top and a drop out in the center of it. Check switches in case any of these matter. It seems not. Okay, so it's similar. I think it's purely the quality of the diagram and the manual, really. Yeah, so we'll go to TP5. I think that's probably right. TP5 is where? Where's 6? Where's 5? There's 4, 8, 7, 5. There's 5. Okay. Now 5 is supposed to be fairly much a square wave. Got some jitter going on there. But yeah, pretty much. Yeah, it shows a step down in the middle of the top part of the waveform. Shows it stepping. I'll clean this up by adjusting the trigger a little bit. Or not. I don't know. Right. It's interesting bit of jitter there. Whether that's supposed to be there, I don't know. Just trying to see if I can clean it up a little bit. Oh, let's do a single. There you go. Right, that's what it's supposed to look like. And the picture in the manual looks pretty much like that. It's got little steps in it. So yeah, I think that's okay. And TP6 has got upward spike in the centre. So 6 was 8. 6 is over there. I'll have to reclip. There's 6. Is it on? Yeah. So re-triggering. And yeah, that's pretty much what 6 is. Let's do a single on that. So yeah, that's fine. That matches as well. So those waveforms pretty much match. There's no information about the time bases, that kind of thing. I should be able to find a 2.5465 megahertz clock signal at A7TP1. So test point 1 is that one. And let's do a normal trigger on that. And that's what I'm getting. 2.5632. 2.54632. Slightly off. I don't know if there's an adjustment. I don't know if it even matters, to be honest. It's such a small amount out, but 6.5, it's not much out there at all. So at 50 hertz, does it matter? Don't know. Let's turn this off and see if there's an adjustment for that. If I need to, I've got wiser cards to use on this, so I can actually lift the board up. There is no adjustment. It's fixed capacitor value, so it probably doesn't matter that much. Otherwise I'd have put an adjustment on the board. So it has a interesting arrangement there. So yeah, this is fixed capacitor just here, which is across the crystal. So that's probably what's tuning it. So yeah, probably doesn't matter too much. If there's mattered, they would have put an adjustment on it. Okay, so that part seems okay. So apparently the next thing I've got to do is get the A8 board and take it out of the unit, which is this board here. So okay, go soften it, yep. Take that out. Go to one side. And apparently I'm supposed to short out the A3 TP3 test point to the chassis. Okay, I can probably manage that somehow. I'll have to come back, I'll have to sort some leads out. Okay, so I found some clip leads to use. I've got a couple of plain meter leads which are clipped together. Just make a jump. I need to get some jumper clip leads. I keep finding situations where I need them. So I've got it clipped onto chassis, clipped onto TP3 on the A3 card as per the instruction. Now I'll turn it on, see if it displays -1888. And it does. So that looks correct. It's got decimal points on that one, but no decimal points on that one. I don't know if that matters. Anyway, so that seems to match. Okay. Well, we should move on then. Next step is on A2 board, which is the digital display. Check the circuit mode on indicators, unit lamps and decimal points all light properly. Use the following procedure. Perform self-test for test 1 with LC and R functions yet. Turn line on. Operate function and circuit mode switches to light each circuit mode indicator lamp in normal operation. Okay. So I know most of the lights are coming on anyway. Trigger lamp, yeah, it comes on. Decimal points. Yeah, okay. 2 decimal points in that one, 1 decimal point in that one. Out of range, yeah. I know all these indicators work. I've seen them all working, so that's fine. I don't have to do that test. So rather confusingly, after that step where it says to check all indicators, it says there's a yes arrow and there's nothing next to it. So I'm not quite sure what the next step's supposed to be. Bit odd. So here's the screen of the manual. So this is the section I'm talking about just now, and it says yes, nothing. But if you look a bit below this, there's a starting of an arrow here. So I'm guessing this is the continuation. I don't know why I didn't see like bring the arrow down here. I don't know what the story is there. So I'm guessing this is a continuation of the next stages. So this is what I'll work through now. So next thing I've got to do is this A8 board. Let's just zoom a bit more so it's easy to read from further away. And we'll go through this stage and see what happens.